Okay, just now I stopped until this one, right? So now I show you this one. This one is gas. Okay, so when you are talking about gas, okay, remember molar volume is normally same for all gas. Molar volume same for all gas. Just remember in which condition, RTP or STP. So remember this one. So they are talking about volume. So when you are talking about volume, you have to find out volume, number of mole times molar volume at STP. So molar volume and here 1.5 mole times molar volume is 22.4 dm cube per mole. So can cancel off these two. You can calculate lah, dm cube. Okay, clear? Okay, so next we go here. Now we summarize everything. So this is what we call mole concept. Okay, mole concept. Center of this mole concept we talk about mole. Alright, mole. Okay, volume, gas, number of particle. They can be atoms, they can be molecule, they can be ions. Atoms, element. Molecule, covalent compound. Ions, ionic compound. Okay, clear about this, So here what you have to do, complete the diagram. Okay. From number of mole to get volume of gas, you have to times molar volume. Here divide molar volume. To get number of particle, from number of mole, C, times Avogadro constant, divide Avogadro constant. Okay, remember Avogadro constant is 6.02 times 10 to the power of 23 particles, and these particles always refer here. And these particles, you must know who they are. And this one, mass. Mass, gram, unit, unit. This one also unit. So number of mole, using number of mole to get the mass, okay, you have to times with molar mass. Here you have to divide with molar mass. Okay, to get number of mole, you divide with molar mass. To get mass, you times with molar mass. Okay, clear? Alright, now we go to numerical problems. Numerical problems, when you are talking about numerical problems, you will always back to these three parts. Okay, mole is the center. Mole is the given the symbol N. Alright, so this one. First thing, we learn about particles. Second, we learn about mass. Third, we learn about volume. So you have to complete this. from mole to mass, mass to mole. Alright, so molar mass. Okay, just now what you learned, the same thing, the same thing. Okay, to get mole from given mass, you have to divide. To get mass from given mole, you have to times molar mass. You see, particles. From given particles, you determine mole. What you should do, you have to divide with Avogadro constant. From given mole, you get number of particles, you times with Avogadro constant. And then the last one, you see, volume, molar volume. I already told you there are two conditions. One is room condition, another one is standard temperature and pressure. So what you should do, to get volume from given mole, you have to times molar volume. To get volume, no, to get number of mole from given volume, you have to divide with molar volume. Okay, clear. Now we go to the question. Okay, now we go to the question. Okay, the first question. Look at this question. Okay, solve the numerical problem. What is the volume? You have to find out the volume. Okay, in the given mole of sulfur dioxide gas. Okay, you see, you notice here, you are given molar volume, okay, at STP. So meaning to be, everything that given to you is carrying the meaning for you, or it is useful for you. So in order, you rewrite everything. Volume of sulfur dioxide gas is actually number of mole times molar volume. So what you get? N you got here 0.3 mole times molar volume you get here. So 22.4 dm cube per mole. So you can cancel off the mole, and then what you get is dm cube. So 0.3 times 22.4 dm cube. So you will get 6.72 dm cube. So this is the same answer as given answer. Correct or not? So you try the rest. Okay, probably the question number 5, you might have some problem. Okay, because they ask you how many aluminium ion. They ask you how many aluminium ions. Okay, and if you notice, okay, you see, if you notice, they give you the formula. Am I correct? Okay. Now, this is a combination question. When you are talking about combination question, they may ask you from volume, get the mass. From mass, get the number of particles. From particles, you get the volume. And they are always going around and around about the number of mole. So now we solve this question. You see what are the information given to you? Oxygen, relative atomic mass, Avogadro constant. They already give you this one, right? So how to solve this question? So this is aluminium ion. Aluminium ion is particles. Okay. And what is given to you? The mass. Okay. So that means from the mass, you are going to find out the number of mole, as number of mole is the center of all the problem solving. So then you are going to get the number of particles here. And this number of particles is actually referring to the aluminium. And from here, you have to go for the ions of aluminium. Okay, so before I teach you, I want you to find out how to get this aluminium ion. Okay, you notice or not? Given information here, Al2O3. Okay, Al2O3. Al2O3 here is Al3 plus O2 minus. Now, this is the formula. If I said aluminium ion, the aluminium ion's formula is Al3 plus. Oxide is 2 minus. So, now you check the number at the bottom. So, there are 2 aluminium ions and there are 3 oxide ion. Alright. So, now you already got how many are there? There are 2 aluminium ions in one molecule. Now, in not to say not molecule, 1 mole, 1 unit of aluminium oxide. So, the mass given here 20.4 gram. And to get the number of mole, you have to divide with molar mass. And what is the molar mass of aluminium oxide? Divide by Al2O3, right? So, Al is 27 plus, remember there are 2 27 plus there are 3 oxygen. So, 3 times 16. And then you will get number of mole. What is the number of mole? Okay, you check here. Right. Okay, so 20.4 divide by 2 times 27 plus 3 times 16 and you get 0.2. So 0.2 mole. And this is the number of mole of aluminium oxide. And now you are going to get how many unit in aluminium oxide. So what you should do? You have to times with Avogadro constant. So times with 6.02 times 10 to the power of 23. Now what is the answer? Okay, now you see the answer just now, times with 6.02 times 10 to the power of 23. What do you get? 1.204 times 10 to the power of 23. So meaning to be the particles 1.204 times 10 to the power of 23 units of Al2O3. Okay. Now, just now, how many aluminium ion? So, get this answer 1.204 times 10 to the power of 23 times 2, you will get the same answer times 2. 2.408 times 10 to the power of 23. 2.408 times 10 to the power of 23 aluminium ions. Okay, this is the answer. Now check the answer. 2 comes from where? This is the number of aluminium ion. This is number mole of Al2O3 and this one is Avogadro constant. Okay, so this is the method and this is the answer. Clear? Okay.